whatever is given to you. So for number 31, you're given the volume of a cone, and it's 1/3 pi r squared times h. So our goal is to write that in terms of x, so that all you have in there is x's and the numbers, instead of with the r squared and the h. So this is the volume formula for a cone, 1/3 pi r squared h. You had to memorize that last year, yes?
Yeah.
No.
Well, if you were in this building, you had to memorize it. Yes, let's hope. I see some notes. I might need to be talking to some of those teachers over there.
We were like, when she said don't do it, get some paper for the notes. So it wasn't
Okay.
I'd like it.
All right, so with number 31, so we've got this cone.
Looks like a TV.
Kind of does look like a teepee, huh?
Of course,
The radius is 2x, and the height is just x squared. So how would I take the volume formula and write it in terms of x, using the given information from the diagram? That looks a little better than mine. What would you do? Caitlin?
Volume equals 1/3 pi, and then 2x squared.
So instead of r, she said 2x squared. Is that how you have it written? Yes? So if you're squaring the radius, okay,
Shouldn't 2x be in parentheses?
the 2x needs to be in parentheses because you're squaring all of that value. So this is all the radius, and all of that radius needs to be squared. Not just the x, but the whole quantity. So we need to square both pieces, so that has to be in parentheses. And then the h is also squared. It's also x squared. But that's what was given to you. And you don't need to change that because it's just the height. So we have 1/3 pi, and then in parentheses that 2x, that quantity squared, and then the x squared again. So using the information we know about exponents, if there is a quantity that's squared, that exponent has to square both values in the quantity. So we would have 1/3 pi, and then that becomes 4x squared plus then the x squared for the height. Now because this is a formula, we're keeping it as a formula. Pi should stay in there. Don't calculate it as 3.14, but keep it as pi because we're not really calculating the area. We're just rewriting the formula so that we have it in terms of the x variable instead of having the r and the h. So Sarah, if we try and simplify this, what numbers or values can we try and combine together?
4x squared, x squared.
Okay, so the 4x squared and the x squared. So if we're just looking at the x's, this is all being multiplied. So how do you combine those exponents when you're multiplying? You add them. So that becomes x to the 4th. And then what else is the same up here? What else can be combined?
4 and 1/3.
The 4 and the 1/3, these are both numerical values, and we're multiplying that whole quantity. There's no addition signs. This is all being multiplied. So the numerical values of 1/3 times 4, we can also combine those together. Aaron, 1/3 times 4 is just
4/3.
4/3. Yeah, that just becomes 4/3. And then we have the pi. So the volume of a cone is 4/3 pi x to the 4th when given this information about the height and the radius of a cone. So if I had a different height and a different radius, obviously that formula would change. But now I could find the volume based off of any given x value. Questions? How about another one? Virginia. 34? So number 34, a red blood cell has a diameter of approximately 0.00075 centimeters. If one of the arteries in your body has a diameter of 0.0456 centimeters, how many red blood cells could fit in the artery? And then it says write your answer in scientific notation. So yes, you could plug these in your calculator as they are written. And have the calculator figure out the scientific notation. Yes, I mean, I know the calculator does pretty much everything for you. But if you apply the concepts of the scientific notation to the values that they give you, that's how I try and like you to approach this problem. So if you look at 34, how would we write the diameter of a red blood cell in scientific notation? So that's the number 0.00075. How would that be written in scientific notation? Virginia? Right. So because we're moving the decimal place to the right, it gets a negative exponent as we're writing in scientific notation. And then the diameter of your artery, Virginia, do you have that written in scientific notation?
4.56 times 10 to the negative second.
You said 10 to the negative second, okay. So our goal is to figure out how many red blood cells could fit across the arteries. How would you figure that out? Sarah?
Would you divide 4.56 times 10 to the negative second by the other?
Yeah. So take the diameter of the artery, divide that by the diameter of the blood cell. When you're dividing, we're going to group the numbers together and actually divide them. And then the exponent values, we're going to group those together as well. So Sarah, if we just look at the exponents first, what do you do with those exponents? Right, so technically you would be flipping these, so you would have 10 to the fourth and 10 squared. So that would be 10 to the second. Or you could think to yourself, -2 minus a -4 is really -2 plus 4, so that gives us 10 to the second. And then the two numbers in front, you're actually dividing those two numbers in front. So 4.56 divided by 7.5. 0.608. Now, the rule with scientific notation, the first number has to be between what? 1 and 10. So this isn't quite in scientific notation. If we bump that over one more time, we get 6.08 times 10, and then what's the exponent? To the first. Because we're taking it and moving it to the right. And when you move to the right, you're decreasing the exponent instead of making it larger. So it wanted it to be written in scientific notation. So we have 6.08 times 10 to the first. And how many red blood cells? So this is the number of red blood cells. So really, this number would make more sense if we just wrote out the number without using scientific notation. But the goal was to get you to use that scientific notation process. So about 61 red blood cells would fit across the artery. Are we okay back there?
I dropped my thing and he thought it was glass, so he thought it was gonna break.
It is glass.
Did it spill anywhere?
No, it's plastic.
Oh.
He thought.
Oh man.
It has a lid though, right?
Yeah, it just shatters everything.
Oh, really? Any other questions?
Yeah.
No?
Oh, this game. Okay,
Yeah.
so I was starting this weekend and I saw this really old calculator and I was gonna buy it for you, but I didn't. It was really, it was like a brick. But it
Did you take a picture of it?
I did. I'll show you a picture.
Alright, if you can put that homework on the side of your desk, I will come around and check it in a little bit as we're kind of talking through the notes. And take out page 7, section.
There's the bond for it.
Oh,
And it was huge.
Look at that.
Yeah.
That is really cool. That is quite ancient.
I don't know. I like it though. That was a bond for it.
So page 7, section 5.3.
And then
Yeah, we're gonna skip it for now. Not totally skip over it. So, in your packet, we went from section 5.1 to 5.3. Section 5.2 talks about graphing polynomials. And then in the back of the packet, section 5.8 also talks about graphing polynomials. So instead of starting graphing now and then graphing in like 2 weeks, as teachers, we kind of thought that the book wasn't organized as it should be, and that happens sometimes. So we flipped the chapters or the section around a little bit. So the first group of sections are all algebra based. We're going to talk about those first so that you can apply those rules to the graphs. Because otherwise, like, you're not going to be able to graph without fully understanding. But we didn't write the book, obviously. Somebody else did who probably wasn't really thinking about how teachers should be teaching. So we are going back to 5.2. It's just at the end of the chapter when we'll be like doing those two sections together so that we can thoroughly graph these problems. But you'll see that like today, section 5.3 is pretty straightforward. I mean, we're adding and subtracting, which isn't too bad, adding, subtracting. We're just adding polynomials with a lot of powers, but that doesn't make it really any harder than it would be to add an x plus an x. We'll also be multiplying them, which if you remember FOIL, kind of similar. We'll be doing a little bit of that, but it isn't called FOIL. It doesn't get a fancy name. Just multiplying. But just to kind of remind you, when you're adding, if we have 2x plus 5x, and I know this isn't there, but just to get your thought process, how do you actually add those? What are you adding when you add 2x plus 5x, Kate?
Just the coefficients.
Yeah, so just those coefficients, so that would become 7x. You don't square anything because there are 2 x's there because you're not multiplying. You're just adding, and when you add like terms, you add the numbers in front. So in this first problem, we have a cubic. So this is a cubic polynomial because the power is x cubed. So we have 3x cubed minus 2x squared plus 4x minus 6. These two polynomials are stacked on top of each other. They're aligned vertically, kind of like when we used elimination. You can add things vertically if your like terms are lining up with each other, and sometimes it makes it a little easier to add. So underneath it, we have x cubed minus 5x squared. There is no x term, that's why there's a space there, and then there's a plus 3. So if we're adding these, you're adding the coefficients in front to combine the two polynomials together. So Kate, what would you get if we added the x cubed terms together?
4x cubed.
Yeah, really there's a 1 sitting in front of that x cubed, so now it's 4x cubed. Again, that x cubed doesn't become x to the 6 because we're not multiplying. You're just adding, so you're literally taking the numbers in front. How about the x squared terms, Kate?
Negative 7x squared.
The x's?
4x
Right, because there's just an x there, nothing to add it to, and then the number would be
minus
minus 3. That's all you're doing for the problem. So now I have a new polynomial. Polynomial has exponents to it, so this is a polynomial by adding the two together. So we could like graph them separately, which we will later, and then we could see what the graph looks like when they're added together. But right now, just kind of getting the process complete for us. That's it. Questions? So the second one underneath just has a written horizontally. If you prefer to add them vertically, you can always take them and stack them. So if you think it makes more sense to have them written vertically, that's fine. If you can add them horizontally, then you're just literally pulling a like term from the first part and a like term from the second and grouping them together. Total personal preference there. So we have 2x or y cubed plus 7y squared minus 6y. You're adding that to negative 4y squared plus 3y minus 9. So how about the 2y cubed? What would that become, adding its like term together? Yeah, just 2y cubed. So if you look at the second parenthesis there aren't any y cubed terms. So that one's done. How about these x or y squared terms? Good. So plus 3y squared. And then the y's? And finally, minus 9. So the 2y cubed and the minus 9 had no like terms to combine with it. Questions, Paige?
Would you
distribute the positive, like imaginary positive one, so it would be positive
You
or
could distribute it, but if you're distributing or multiplying by a positive times a negative stays a negative.
Oh, okay, yeah. I see
So-
that one then. I was thinking it was a negative.
If it's a negative like the next ones, then yes.
Okay.
Yeah. So if there's a negative sign in front, yes, you need to distribute the negative one through. If it's a positive, then it doesn't change the signs. So looking at the second group, it says we're subtracting, but really when you're subtracting, you're distributing that negative through. So Paige, if you distribute the negative through the second set of parentheses, what does it become?
Negative 6x cubed minus 3x squared plus 7x minus 5.
Right. So when you're subtracting, you're really distributing that negative through, and then we're just adding the terms together again. So distribute the negative through, and then again, just add vertically. So Ethan, if we add these together,
You get x to the third minus 9x to the 2.
Good.
This is how many steps. 4x and 2.
Good.
That's
any questions? So then for the one underneath, it's not written vertically, but again, if you prefer to write it vertically, you can. Just make sure you're distributing that negative to everything. So this negative affects everything that follows it. So we have a negative 12x squared, a positive 9x, and a positive 3 when you distribute that through. So I rewrote them vertically, just pulling that negative through and then lining them up vertically. But again, you don't have to do that. You could keep them horizontal and work through them that way. So is it, if we combine our like terms here, what do we have for the x squareds?
Negative 12x squared. Oh no. Can you repeat the question?
So I already distributed the negative through.
Uh-huh.
So if we combine our like terms for the x
okay.
squareds.
So we're gonna have negative 4x squared minus 14x plus 8.
4x.
Oh, 4x plus 8.
14?
Yep. Oh yeah, that makes sense.
Because the negative got distributed through to switch the signs. So it was a negative 9x, but it becomes a positive 9x because distributing the sign. So then there are two problems below, I believe two problems, yeah. Two problems below where they're written horizontally. Again, you can keep them horizontally if you prefer to have them, or you can write them vertically. Sam, what do you have for number 1? What terms are we combining there?
You're combining negative 5t and positive 3t, which would be negative 2t squared. And then you have negative 7 and positive 6, which becomes negative 1. But that's like broken down.
Okay, so you said negative 2t squared, and then what else did you say?
In front of negative 2t squared, there's negative 2t cubed.
Right, negative 2t cubed.
And then after negative 2t squared, there is 8t positive. And then after that is negative 1.
There we go. And then a negative 1.
I don't like when t is.
You don't like having the t in there.
Yeah, because like,
It looks like an addition sign.
yeah, I just like.
So distribute the negative through first, and then notice that the first parenthesis isn't in order. So when you're combining those like terms, make sure that you're grabbing those correct pieces. So the negative 5t squared and the positive 3t squared, they group together, and then the 6 and the negative 1. The others didn't have a like pair to match with. So the last one on this page, we have 4p squared minus 6p minus 6 plus 8p squared minus 7p plus 4. Does anybody have that one?
You want the answer? You want
Yeah.
the
No, you can give me the answer.
12p squared minus 13p minus 2.
So that one you don't have to distribute anything through because it is a plus sign. You're just combining those like terms. Questions? So then if you look at the next page, we did a little bit of adding and subtracting. So now we're going to try and multiply polynomials together. We're going to multiply horizontally. You can't use FOIL because FOIL is when you multiply x plus 2 times x plus 3. And here we have x minus 2, two terms, which is, remember, that binomial, times a trinomial. So you can't really use FOIL. But how would you describe how to approach this problem? What would you be thinking about if you're trying to multiply these? Sarah?
You multiply all the ones in like the second parenthesis by the first number and then by the second number.
What other word could you use for that?
Distribute.
Distribute, yeah. Good. So you're going to distribute the x through the entire second parenthesis, and then we're going to distribute the negative 3 through the entire second parenthesis. So Sarah, if we distribute the x through, what do you get?
X cubed plus 2x squared minus 5.
Good. So now a little trick, when you go to multiply the negative 3 through, if you line them up vertically, it makes it a lot easier to combine your like terms. So when you're multiplying the negative 3, you get negative 3 times x squared. So if I place that right underneath my x squared term, then my terms are lining up vertically with each other. I'm not writing any more information than I would have written if I wrote them horizontally, but now my pieces are already grouped together as their like terms. So negative 3 times 2 makes negative 6x, and then negative 3 and negative 5 is a positive 15. So either way, you're writing a big long list, or you're putting them vertically, and then you can quickly add them together. So Sarah, if we add these, we have x cubed because it doesn't have any pairs.
Minus x squared minus 11x.
Right. Any questions with that? So if you look at letter B is just kind of set up in the opposite, where you have x cubed minus 3x squared plus 10, and then when you've got x plus 1. So you could start with the front, and it would be a 3-step process of multiplying. You distribute the x squared through, you distribute the negative 3x, you distribute the 10. Or you could flip them and write it the same way as letter A is written. Multiplication can be done in any order. So you could actually take x plus 1 times x squared minus 3x plus 10. Which I think is easier because you're multiplying 2 pieces instead of multiplying 3 separate pieces. But it's totally personal preference. So if you flip them, you're still going to get the same exact answer. I just rewrote them to have that x plus 1 first. So if we multiply this, again, it doesn't matter what order you chose to do it in. But less mistakes are made when a 2 term is multiplied with a 3 term. So we would have x cubed, 3x squared, and then plus 10x. So that would be taking the x through. When we take the 1 through, we would have an x squared, a minus 3x, and then a plus 10. Squeeze that guy in there. So that's just taking the 2, flipping it so that the x plus 1 is in front. So Paige, if we combine our like terms, what did you get?
X cubed minus 2x squared plus 7x plus 10.
Good. Any questions? So the last type of problem then is multiplying 3 binomials together. So instead of just doing the 2, we now have x minus 3, x plus 7, x plus 1. Again, you can multiply any 2 together at the same time, but you can't actually do 3 at the same time. So you have to pick 2 that you want to multiply or FOIL, and then you're going to take that answer, that product that you get, and FOIL a second time or multiply a second time. So if you want to keep the x minus 3 in front, so that whatever you have behind it is a trinomial, then you would always want to multiply those last 2 together. And then if you do that, once you multiply, your problem would be set up like letter A, so that you always have that 2 term in the front and the 3 term behind it. So David, if we multiply x plus 7 times x plus 1, what do you get when you FOIL that?
You get x squared plus x, and then 7x plus
Good. So x plus 7x makes
8.
8x, and then you said plus 7. So after you FOIL that, put parentheses around it, take the x minus 3 or whatever was sitting in front, and then we need to multiply again. So it's a 2-step process. You FOIL first, and then you're going to distribute second. So now we'll distribute the x through, and then the negative 3. Grace L, what do you get when we combine our like terms?
You get x cubed plus 5x squared. Sorry, I can't.
I'm sorry, huh? Yeah. 17. So you're getting 17x and then a minus 21. So see if you can complete the last two problems if you haven't done so already. Yes. Um, Someone like to go up and do letter B?
I would like to. I would love to.
Okay, Sam.
Do we?
Can you write in
I will
English?
send
I
you.
can't. I might be wrong.
Okay.
Is that okay?
Yeah, let me see what you have.
This guy here.
I'll take it. That is it. I don't know what it did. That should be 24.
I have x cubed minus 6x.
So I get two equations from doing this, right? And then I add them together. Are these right?
This is right. X squared minus
Plus 16.
4x squared right here. 4 times
Negative 4. Okay. So now I can Wait, what is negative 40 plus 16? It's 24.
negative.
Oh,
Yeah. Hey, shh, everybody be quiet. Watch me do letter B. No. Please don't see me on the hallway afterwards. Okay. First do these two. Okay. You get x squared minus 10x. Oh god, I don't remember now space. Plus 16. And then you have x plus 4. Okay. Alright, so that's your first step, or slash second step, depending on how you see it. Then you gotta FOIL these, right? And then it becomes x cubed minus 10x squared plus 16x. And then your second equation is 4x squared minus 40x plus 64. That worked somehow. And then your final answer will come out to be x cubed minus 6x squared minus 24x plus 16 plus 64. Yes, plus 64. There you have it.
So again, you should have x cubed minus 6x squared plus 24x and then plus 64. The last one, you should end up with x cubed minus x squared minus 17x minus 15. Nice job, Sam. All right, so as I'm passing out these tests, homework are the multiples of 3 on the 349 and 352. These tests were either A's or B's or E's. There were no D's. They were either A's or B's or E's. Very disappointing. I don't know if it was because it was before Thanksgiving versus after Thanksgiving. But
I forgot his
this is the first chapter of actual Algebra 2. Chapters 1, 2, and 3 were not Algebra 2. They were Algebra 1 review.
The back is on
I don't know what.
I'm just happy I won 35 actually.
So, because of the importance of this material, ladies and gentlemen, you need to be quiet. I'm trying to talk about this. Because of the importance of this material, and it really is so important because everything builds off of this. Like all of Algebra 2 is based off of this material in this chapter. I have a worksheet up here. This is a requirement. If you receive less than a 35 out of 50, which is less than a 70%, you must complete a review worksheet and receive an 80% on that review worksheet to prove that you know the material. Then you will be taking the test over again. I have a totally different test that I have already made. You must retake the test again to prove that you have a solid foundation on that material. Your mom or dad will also be getting an email from me, if not by the end of the day, sometime tonight, stating that you performed poorly on this, that you will be completing a review assignment, and then you'll be given an opportunity to take another test. You're taking the whole test, not just part of it. Again, if you received less than a 35 out of 50. The review worksheet I will have up here on my desk. I need you to grab one of the review worksheets. Even if you got a C or a B and you want to redo the test, you can. Totally up to you. I will take the better of the two grades. So if you got a C and you're saying, hey, I'd rather have an A, I will take the better of the two grades, but you still have to do this review worksheet. So please come grab a review worksheet. There are directions at the top of it. Yeah. It's stapled together.
What'd you guys
For those of you who received an A or B, nice job.
Wait, are these interviews or the test?
It's the review for the test. There's a stapler here that you can staple them together. Only if you want to.
So if I got it,
You can still redo it.
Do we do this?
It's due on Monday.
So you want me?
Matt, you were like 9 points away from getting.
Just keep that with you.
Do you want this back?
Keep it for now.
When it's wrong,
You have to.
So, why cause?
I mean, if you want to get a better grade, you can do it. It's up to you.
when is this due?
Monday. For now, yeah. I didn't pass out. I didn't have time to pass out folders. So take your test with you. I'll pass out folders maybe tomorrow. Tiny quiz tomorrow on the exponents.
Oh my god.
This is the worst grade. So, worst grade I've ever gotten on anything.
Hey, someone left their notebook on the ground.
Yeah.
Whenever you
Virginia.
Yes, ma'am. I was thinking
you need to do this.
what's
Do
it
you
use?
have this done?
Yep.
I got 64.
Yeah.
I was kidding.
Oh, wow. That was
And then after you do that, I'll look over it to make sure. If you want to.
Is it like an average?
I'm gonna take a better grade. I don't have any little mistake that I just have to do them. I don't also put the stress on yourself to redo it.
I think I could definitely do better on that. It was just, I remember I was up late that night, bro. I think.
You still did well though.
Yeah, I mean, I didn't get that.
Comparatively
Oh, I got
speaking, you
so
did
nervous.
well.
You got me nervous on that. You were
And I
like,
didn't enter them in I didn't enter them in power score yet
I
either.
checked. I was like,
And no. I was kind of saving them.
okay, fine.
See ya.
I just thought